Hello and welcome to Ansys-Tutor. In this video, we would see how you could model a pulsating flow problem in ANSYS without using any UDF. Let's know about the problem. It's a pulsating pipe flow problem. The flow velocity is 0.0001 meters per second for first 1 second, then flow stops for the next 2 seconds. Then it repeats the same velocity. Likewise, the flow continues in a periodical manner for the next 10 seconds. Simulate such type of problem in ANSYS Fluent without using any UDF. Let's know about the objective of this tutorial. At first, you would learn where to place the transient table data file in the ANSYS file folder. Then you would learn what is the format to write the transient table file. You would learn how to write the transient table data for this tutorial setup. How to link the transient table parameters into the boundary condition in Fluent. How to create the solution output plot between the time and the velocity. To reduce the tutorial time, we have skipped the geometry creation and meshing process. If you are a beginner, watch our previous tutorials to know the detailed procedure regarding the geometry creation and meshing. Here is the details of the geometry. It's a cylindrical pipe geometry. Its diameter is 50 mm. It's extruded along z-axis up to 500 mm. In meshing, we have inserted sweep meshing method, axisymmetric algorithm, with O-grid divisions. The number of O-grid divisions is 10. Adaptive meshing is turned on. With a highest resolution of 7. Open the setup. Select the double precision model. Check the mesh quality. Check the meshing, make sure that the minimum volume should not be negative. Let's know about where to place or create the transient table data file so that it would be linked with the solver without any error. Open the ANSYS file folder, make sure that create the file in the specified folder only. Open the DP0 folder. Open FFF. Open Fluent. Right-click and create a new text file. Name it without any space between words. I have named it pulsating_flow. Copy this file name into the clipboard. Now we would create the transient table data text file in the Fluent file folder. Before proceeding, let's know about the parameters in the transient table. The first data to be entered is the profile name. Name this to provide the reference to the data. The next value to be entered is the number of parameters to be input into the data file. Then the data denotes the number of data points. The next parameter is the periodic, which says whether the data is to be repeated in a periodic manner or not. If periodic, enter the value 1, otherwise enter 0 for non-periodic input. Here is one example of the tabular transient data file. Here XYZ denotes the profile name, number 2 denotes the number of parameters involved in the table. These parameters are time and velocity, so the value is 2 here. The next value is the number of data points, which means the number of data that you want to input as row in the table. In this table, there are 4 rows of data, so it's written as 4. The next value denotes whether the data is to be repeated in a periodical manner or not. If you want the repetition of the table data at the 4th second onwards, then put 1, or else put 0 for non-periodic data input. Note that the time 0 data would not be repeated as it's only for initial simulation only. Only the next 3 row data would be repeated periodically if you select the periodic input option. Also, note that only use the tab and enter key to enter the data values to avoid any error. Let's write the transient table data for the current problem simulation. Open the text file. Write the profile name first without any space between the words. Then press tab and enter the number of parameters as 2. Then press the tab key and enter the number of data points as 4. Then press tab and enter 1. As we want the data to be input in a periodical manner. Press the enter key and come to the next row. Now enter the time and the velocity in the table. Fill the table with all the time and velocity values. Save the text file and go to the Fluent setup. Let's know how to link the data file with the ANSYS Fluent CFD solver. In the console, write File and press Enter. Then write red-transient-table. Press Enter. It would ask for the file name. Paste the name of the file copied, or write down the name of the text file. Then enter the extension .txt into the file name and press Enter. It would read the transient table data and show the number of data input. Select transient time. Select the model as laminar. In the material, select the fluid, open the Fluent database. Select water liquid. Click on Copy. Go to the cell zone. Select the water liquid as the material. Click on OK. Go to Boundary Conditions. Click on the inlet boundary. Keep the default velocity inlet boundary type. In the velocity magnitude drop-down, select the velocity profile name. Here the inlet boundary velocity would call the transient table data in each time step. Click on OK. Keep the default outlet boundary condition. Select the coupled solution method with green Gauss cell-based gradient spatial discretization. Keep the default residuals. Let's know about how to generate the time versus velocity plot. Click on Report Definitions. Click on New. Select Surface Report. Select Facet Average. Select the velocity as the field variable. Select the inlet surface. Check the Report File and Report Plot option. Click on OK. Similarly, create another surface report definition for the outlet boundary. Click on Close. Click on Initialization. Select Compute from all zones. Click on Initialize. Click on Run Calculation. Enter the number of time steps as 100. Enter the time step size as 0.1. The maximum number of iterations in each time step is 5. Click on Calculate. The calculation gets completed. Open the report definition plot for the inlet. Go to the File menu and select Save the picture. Select the image file format as JPEG. Select the white background option. Uncheck the Use Window Resolution option. Enter the width as 1280 and height as 720. Click on Save, select the file location, click on OK. Similarly, save the image file of the outlet report definition. From the chart it can be observed that the velocity is varying in a pulsating manner at the inlet, which eventually results in variations of the velocity at the outlet. With this, let's conclude this demonstration. Hope you would like this video. Comment below for any queries or suggestions. Please subscribe to our channel. Stay healthy, stay safe.